Hello everyone, welcome to my YouTube channel TechTalk with Rais. Today we are going to discuss a very important topic related to data security. So without wasting much time, let us move on to our today's topic, which is cryptography use cases. So everyone must have heard about cryptography. We will discuss different use cases of the cryptography. Today's agenda is typical data transmission topology, cryptographic security use cases, cryptographic algorithms, public key cryptography, one-way cryptographic functions, which are also called hashes, and symmetric key cryptography. So let's move on. A typical data transmission topology. This is complete pictorial diagram where there are at a very high level there are two parties. One is sender, another is receiver. In between them there is a communication channel, and a very important thing, that is data. This is the message or data which needs to be sent to the receiver, and this should be actually received successfully here at the receiver's end. So total there are four things in the typical data transmission topology. The one is sender, receiver, communication channel, and most important thing is data, for which the security must be provided. In this slide we'll discuss about different use cases of the data security. So in the cryptography, what kind of security can be provided to the data, this message, in this pictorial diagram we'll try to understand. There are two parties, one is Alice, that is sender, another party, that is Bob, which is receiver. This particular message, hello there, it's me Alice, this needs to be sent to the successfully to the receiver, and this should actually successfully receive this particular message. And for that there are different use cases, like whatever this user, whenever this user is going to interact with the receiver, this user must be authenticated, right? So this particular user must be authenticated, then only the message transformation or message transfer will be successfully possible. So one use case for that is basically authentication. Another use case, here you can see this is message. This complete message is sent over the internet or some communication channel, and then it goes and received by this receiver. It is this particular message is there in the cloud or in the internet or somewhere. So this particular message, if we are sending just like that, this can be, there are possibilities it can be hacked or someone can read silently. So to avoid that, this message can be kind of encoded in such a way that others cannot read this. For that purpose there are different algorithms or different things are used. Encoding mechanism, encryption mechanisms are used. We'll talk about those things later, but the use case for that is basically this message should be encoded in such form that it will reach to the receiver in encoded form, and it is remains in encoded form over the communication channel, so that no hackers can kind of read this message. So when this particular message is here received at the receiver's end at the Bob, then it will be using some mechanism, this message will be decoded, and actual message will be recovered, which was hello there, it's me Alice. And one also very important use case in this cryptographic security model is this particular message, whatever is sent, this should be received as it is. That means hello there, it's me Alice, this should all received in a proper format and exactly as it is. That means hello cannot be at the index of there, or there cannot be at the index of me, something like that. So this is a part of integrity. So this complete message should be received at the Bob side in a complete integrated way. So there at a very high level I can see there are just three use cases, which is authentication, data privacy, and data integrity. So this is authentication. For the first time this user should be authenticated. Next this complete message which should be encoded, and so that the privacy for that can be maintained. And third one is whatever message is sent, let's say it is encoded in such a way E01 something like that, then it should not reach 10E something like that. So otherwise the integrity will be disturbed. So there are three use cases: authentication, data privacy, and data integrity. let us move on. So in this slide we'll discuss about different algorithms, comparisons, and so many things in this slide I will discuss. Let us go one by one. So for we have discussed cryptographic use cases. We can, from the previous slide we can see there are three use cases. One is strong and reliable authentication, another was data integrity, third one was data privacy. So there are total three use cases: data strong and reliable authentication, data integrity protection, and data privacy protection. In cryptography there are different algorithms, like I told, which are used for different use cases. For strong and reliable authentication, there's something called public key cryptographic algorithms are used. For data integrity protection algorithms are used. And for data privacy there are symmetric cipher algorithms. Let's talk about one by one. So this public key cryptographic algorithm is basically a asymmetric cryptographic type. We'll discuss about all those steps. What is this asymmetric or symmetric? In symmetric, cipher algorithms are based on symmetric cryptography, and for data integrity protection algorithms, the type is basically hash functions. All those things we'll discuss in further slides. For public key cryptography, which is basically used for strong and reliable authentication, for that what algorithms we use to encrypt data and decrypt data, that is RSA, that is DSA, that is ECDSA. You must have heard about these all algorithms. For example, RSA and DSA you very frequently used in SSH, right? SSH keys, different SSH keys, so you people use it. So you can just simply recall it. What is the practical use case of this particular model? That is SSH or TLS or SSL. Similarly, for the data integrity, there are hash functions algorithms. Which algorithms are there? Like SHA-1, SHA-2, MD5, base64. These are algorithms are used. And what is the practical use of this data integrity protection algorithms, which are hash function? What is the practical use case? So digital signature verification. This very interesting use case, that is password hashing. We'll talk about password hashing in further slides. And also multi-part file. These are the multi-part file download or upload. These things are practical use of this hash functions. The last thing, symmetric cryptography. The algorithms are basically DES, AES 128, AES 256. These algorithms are very commonly used, like AES is very commonly used. And the practical use for that is network VPNs. In network VPNs we use mostly pre-shared keys, and also we use some kind of algorithms like AES. So let us move on. In this slide we'll talk about public key cryptography, which is basically used for strong and reliable authentication, and this is also called a asymmetric cryptography. In this particular algorithm or model or cryptography, basically every user is provided with two keys. This is a thumb rule, that every party basically will be given with two rules. With some kind of key generation model or key generation software, this every party is given with two keys. One key is called public key, another key is called private key. Private key is something which will reside at the that particular party or that particular person, and this public key will be shared among all the other parties. So this is the thumb rule. Whenever we are going to send particular data from the sender to the receiver, this particular message should be encoded with the receiver's public key, so that when the data will reach to the receiver can decode that using its private key. So we'll understand little more about this public key cryptography, how the encoding and decoding workflow works in the public key cryptography, and this we can understand from the next slide. So let us move on. So like I said, every party is given with two keys using some key generation mechanism. Let's say there are two parties in typical data transmission topology. There is two party receiver and sender. So to every party in public key cryptography we give two keys. One is public key, another is private key. Similarly to Bob also we have given public key and private key. Next, like I said, this particular public key should be shared among all other parties. So from Alice the public key should be shared to the Bob. Here is Alice public key. Similarly Bob's public key will be shared to Alice. This is called a pre-shared public key. Basically it is shared before the communication. Next, basically this private key is private to Alice, so it will be kept here only. And similarly this Bob's private key is private to Bob, so it will be kept at the Bob itself. Now one more thing is there, like public key can be generated using private key. So this is a very important point, like public key can be generated from the private key. That means if this private key is here, then this public key can be Alice public key can be generated anytime. So there is no need to explicitly store it here. This is why I have crossed it. So basically at the sender side there will be two keys. One is Alice public key, private key, and Bob's public key. Similarly here Bob's private key will be there and Alice public key will be there. Now when we will let's try to send this particular message to the Bob from the Alice. So what Alice will do, Alice will encode from the last slide's thumb rule. The Alice will encode this message using Bob's public key. If you go back and see, the thumb rule says each party has two keys. The thumb rule is encode with pre-shared receiver's public key and decode with non-shared receiver's private key. So here let's go. So that means from using Bob key we will encode this, and the data will be encoded just like this, and it is encoded with the Bob public key. When this particular data is received here, then this entire message will be decoded using Bob's private key, and for that it will use Bob's private key, and the message is decoded. Hello there, it's me, Alice. So this is the complete encryption and decryption or encoding or decoding workflow of the public key cryptography. This public key cryptography is used for two purposes. One, for strong reliable authentication. This also can be used for the data privacy, but data privacy becomes overhead because it takes a lot of effort. It's very costly to provide data privacy using public key cryptography. So this is why at a broader view, public key cryptography mostly used for the strong and reliable authentication. So let us move on. Cryptographic hash functions. So a hash function is any function that can be used to map data of arbitrary size to fixed size values. The value returned by a hash function are called hash values, hash codes, digests, or simply hashes. So there are some properties associated with hash functions. At a very high level, you can think of from hash functions are a function which from the one side the input will be provided and from the other side the output will come. The input can be variable length, but the output will be given to fixed length. So this is simply a hash function. So there are some properties associated with good hash function. A good hash function is always one way. It has fixed length output, and mostly a good hash function is collision free. It provides collision free output. We'll discuss about all those stuffs little more in the next slide. So let's move on to the next slide. We'll learn little more about cryptographic hash functions. So like I said, cryptographic functions takes variable length input, but it generates a fixed length output. So from this pictorial representation, you can think of there is cryptographic hash functions that can be different based on different algorithms like SHA-1, SHA-2, MD5, base64, etc, etc. So from here the input is passed, like here, hello there, this is Alice. This input will be passed. It will generate a fixed length output here. this length will be fixed for a given particular hash function. So next time the length, let's say, is just it got doubled in the input, then still the output will be exactly at of same length. So this is cryptographic hash functions. Some associated properties for this is like fixed length and unique output. So like I said earlier, the length will always be unique for a given particular hash function irrespective of whatever input are passed. And also, let's say one time you generated with this input, you got this output. Next time when you are taking same input, then also it should always generate unique output for the unique inputs. This is one very good property, which is fixed length unique output. Another thing is like a good hash function should always be a collision free. Collision free, that means no two inputs, no two different inputs should provide same output. Like, hello there, this is Alice with small letter E. Hello there, this is Alice with caps letter 8. These two different inputs cannot provide same output, so that otherwise collision will happen. So a good hash function should always try to provide a collision free output. In this particular case, let's say when we change the output from small e to cap c, just a small change, but the complete output got changed, which is completely different than the previous one. Similar to that, there is another very good property associated with the hash function, that is one way. So if we try to, from this example, if we try to understand, we send hello there, this is Alice, we got this. But if we try to pass this as input and try to recover this, that is not possible. That is, this is always one way, otherwise it is like other way it is not possible. Let us move on to the next slide and try to understand the practical usage of this cryptographic hash functions. So like I discussed in the previous slides, that password hashing, digital signature, etc. are very good examples of the cryptographic hash function usage. So today in this particular slide we are going to talk more about the password hashing. What is password hashing? All those stuffs we will learn, but before that, let's try to take an example that whenever you are going to log into particular website which is authentication enabled, then what happens with that? So first of all, user have to go and register themselves, like user and password. User have to provide a username and password. That username password will be saved in the system somewhere, let's say in the DB, and this particular user is thus a registered user. Next time when the user will go, they don't have to register themselves, rather they can directly go and log into the system. Login as in, they will provide a username and password, and system will look that okay, whether this particular person is already available in the system or not. If it is available, then it will, and the password or username is correct, then it will enable it will allow login, otherwise the login authentication will fail. This is overall authentication phenomena happens for every authenticated system. So that particular thing we are going to discuss here a little bit. In this pictorial representation, you can think of there is one application. It has some DB store. For the first time when the user goes, then it is basically operation 1. Somehow it is written wrong. So for the first time, user should register themselves to the system. Whenever he will register, he will pass some DB username, some username and password. So this username and password will be processed and it will directly to the saved to the DB, some particular DB, let's say. Next time when the user will go, then what happens? The system goes and checks that particular password. If that particular password matches with this user or not, if the password matches, the system allows this particular person to log into the system. That means password matches. But here is a big flaw in the system. The flaw is like this. This topic says that insecure password saving scheme. Here the problem here is, if you are while registering your user name and password, the password is saved as it is. That means if any hacker got access to your DB, he can read your password easily, and he can guess, or he can use that password to create threats in your system. That is very dangerous. To provide additional level of security, and what happen next time, like when user goes to the application for the next time to log in, this same password will be recovered and will be matched. Okay, both the passwords are matching, the system will allow it. But the only problem here is basically this password saving scheme. This password saving scheme is very dangerous because you are saving the password as a plain text in the DB. So rather saving it as a plain text, let's try to hash this complete DB password and get a fixed length output and then save it. Like in the second pictorial representation, first of all the person will go and say my DB password. There is something called salting. I'll tell about it. It passes through a hash function. Then out of that you got password like abcd01010. This kind of the hashed password you got. Now let's try to save this hashed password as this in the DB. If hacker gets this hashed password, he can never break the system, because if he passes is he tries to log in with this password, this password will again get hashed, and different value will be here, and then that will not match, and the password the user will not be authenticated. So the thing is how the system processes, like user will, for the first time when user is going to register, user will pass his DB password, let's say. Salting is something which added salt, like some salt strings are added to this DB password, so that this password will become little different. Let's say the password is mydb password plus salting is just salting keyword, so complete password will become mydb password salting. Now this we will send this whole thing will to the password hashing algorithm functions, base 64 md5 sha1 or sha2. Then it will generate a complete arbitrary fixed length output like this. Now we are going to save it in the DB. Next time when we are going to log in into the system, we are again passing my DB password. It will go to add, it will be added with the same salt, same hash function will be provided. So if you just simply recall that property, if you are passing same user input, it will again generate the same output, right? Unique fixed length output it will generate. So unique fixed length output is generated, it is compared with the DB password which was earlier saved. Both are matching and the system is login is successful. Here are two things happening, like registration process and login process is exactly same as a previous one in password saving scheme. The only thing is that while saving this password to the DB, we are passing them through a process called salting and hashing, so that a completely hashed version of this mydb password should be saved here. And if any hacker or anybody gets access to this particular password, even then they cannot access the system, because salting and password hashing is already enabled in the system. That will generate a different password next time. If you will use abcd0101 as input rather mydb password, then it will generate completely different output. If you try to recall this, you simply change the input, the output will be completely changed like this. Next time, instead of mydb password is simply passing abcd01010, then what will happen, it will be completely different, and this will be compared, and those are not matching, login will not be successful. So this is providing enhanced security, along with it is providing complete security at the password saving level. Even someone tries to access it, and by any chance if they get it, still they cannot break the system. So let us move on. Now we'll talk about symmetric key cryptography. So from the use cases, if you recall, there was data privacy algorithm. So this is based on symmetric key cryptography. Symmetric key cryptography means the same key is used for the encryption and decryption. Many times what happens, symmetric key cryptography and one-way hash functions are uh, both are taken into picture, and both are used at the same time to provide additional level of security. So in this particular case, let's talk about symmetric key cryptography. There are again two parties, Alice and Bob. This is the message, and there are pre-shared same key. This green colored key is pre-shared, and this is same. It is not like public key cryptography where there are two different keys. Rather here there are same keys. The same keys used to encode this message. The message is encoded, that is called ciphertext. These ciphertext will reach here at the Bob, and Bob will use the same pre-shared same key to decode in, and finally the message decoded at hello there, this is Alice. And this particular method is used implemented using different algorithms. One is DES, AES 128, AES 256, and practical usage for this is network VPNs. Thank you so much for attending my session. If you like this video, it is helpful, then please like and subscribe my channel. This helps a lot. Thank you.